Hello everybody, I am back and I'm going to continue making terrain for my game. I got it kind of started last time. If you see, I got some weird semblance of terrain, but it's really primitive and rudimentary, and if I look at it from directly above, it just kind of looks like a flat plane. So what I would like to do today is make it so that the lighting actually looks right. And I'm going to do that by fixing the normal here, because I just made every normal of every vertex point straight up, which is not correct. It should point to the direction that the normal is facing. So that's my goal for now. So to do that, I really just slapped this together to try to get it working. And I would like to kind of formalize the terrain. Yeah, I just made it a textured mesh. So I started doing this last time and I decided against it, but now I'm re-deciding to do it. I'm gonna make a former struct here, a formal struct for the terrain that's gonna have all the data that the terrain needs to render and operate. And the reason I wanna do this is because when I'm putting the character, any object in my world, pretty much has to sit on top of the terrain unless for some reason I need it to go underneath. So yeah, it's nice to know where the height of every point of the terrain is, and I need to kind of keep that in memory if I want to use that. So hence the struct here. So what I'm going to do is make a 2D array of vectors. So it's a double pointer of vectors for the position of each vertex in that array. And I probably don't need to actually keep a vector. I probably just need to keep the height of it, because based on where the position is in the 2D array, I can figure out the x and the z coordinate. But for now, just for simplicity's sake and to keep it straight in my brain, I'm going to make it an actual vector for the position. So before I do that, I'm going to make a width and height variable to keep track of how big the terrain itself is. So I got the positions here. And let's see, oh, and I need a textured mesh. That will actually be the mesh of the terrain. And so let's see. Yeah, so then in my game state, I'm going to change this to be a terrain. And so back here, keep everything as it is for now. I just want to make sure that I use the mesh of my terrain. And when I render it, I need to keep that straight as well. So .mesh. So that shouldn't affect anything. It should just work as it was. Yeah. Okay. So with that, I'm going to oh no. Yes, that's that. I'm going to reserve some permanent storage space for the positions, because I'm probably going to need that throughout the game. So to do that, I'm going to calculate the total size that I need for that. So I'm going to say terrain position size is the terrain's width times the terrain's height times the size of a vector 3. All right, so after I reserve this temporary space here, I'm going to say that the state terrain dot, hold on. Let me rethink about this again. So the terrain, I'm going to rename this. I'm going to call this vertex positions. Positions, and then, is it, can I not type? VOSITIONS. There we go. Yeah, so I need the vertex positions, but then I also want to make a vector 3 for the actual position of the terrain, and one for the scale. And that's just so that I could put multiple terrains in my game state and then place them in different positions and scales and stuff. Yeah, so Okay, so anyway, so the terrain, what was I doing? Oh yeah, the vertex positions. So that's a double pointer, so that is going to be a vector3 double pointer. I'm going to say allocate long-term memory, passing in the game state. And how much memory is going to be tpos size. No, that's not correct. So I need the size of a vector3 pointer times t height. So I need a bunch of pointers, and then now I need to iterate through each one of those pointers and assign them all to a bunch of float pointers. So for u32i is 0, I is less than t height, increment that, and then I'm going to say that the states terrain dot vertex positions at I is going to also be a vector3 pointer, just a regular pointer this time. Now for each one I need to allocate more memory, so the state, and I need the size of a vector3, just the regular vector3. Okay, so that should allocate all the space I need. So now once I have that, I'm going to iterate through each one and give it a unique position. Alright, so let's do this here. I'm going to make a vector3 pointer. And that is equal to the states terrain dot vertex positions ij, the address of that actually. All right, so the positions x is equal to this, and the y is equal to this. And the z is equal to this. Oops. Okay, so now I'm going to just pass this all around here. All right, that was a lot of code without a lot of testing, so I'm going to run it and see if it works. Okay, so I completely lost my terrain now. So let me see if I can't figure out why. Ooh. Oh yeah, that's not correct. So that has to be times the t width here. There we go. Got my terrain back as it was. So now that I did that, it should be easier to calculate what the normals are of my terrain. So yeah, that's kind of what I'm going to do here. So let's see, how can I do this? Let me think about this. Let me put a vector3 here, call it norm. And then this is just going to be norm dot x, y, z. And then in this space here, I'm going to actually calculate what that normal is going to be. And I got to do more math for that. So I'm not really looking forward to that. But such as life. Want to make video games, you got to do math. That's the rules. All right, so I'm just going to try to think about this. And again, this isn't going to be performant code. This doesn't have to happen every frame. This is just going to happen once before the game starts, and that's it. Probably same as the sky map. I'm just going to bake it to a text or to a file, and then just have it happen automatically. So to calculate the normal for a vertex, I need to calculate the normal for every face that that vertex is involved in, and then average them together. So for example, let me do this. Let me make some lines here. No, that's not correct. So this, okay, actually I had these all wrong. So it's got to go this one, so it's like this. Okay, there we go. All right, so for this vertex here, it's just going to be these three vertices that affect the normal. For this one here, it's actually these four vertices. And if it's in the middle, it's going to be 1, 2, 3, 4, 5 vertices total that affect the normal. Okay, so I'm going to leave this up and try to figure this out as I go. All right, so I kind of have to consider a lot of special conditions here, because when I'm in the corner, I can't go negative in either the x or the y. When I'm on the other corner, I can't go positive in either the x or the y in this corner. And when I'm on the edge, I can't go positive in the y. When I'm on this edge, I can't go positive in the x. Anyway, I can't go out of bounds is all I'm trying to say there. So let's consider all of these special cases. So if I is equal to 0, then that means I'm on the top edge here. So I got to consider that. Else if I is equal to the texture's height minus 1, then that means I'm on this bottom edge here. So I got to consider that. And then else everything in between. Okay, so if I is 0, that means I'm on this top row. So I also have to consider the fact that j might be 0, and then I don't want to go negative, or j might be at the edge, and I don't want to go positive. So let's consider that. So if j is 0, or j is equal to the texture's width minus 1, or everything in between. So that's this top row. So I have to do the same checks in the bottom row and the same checks in the middle. So all of this is going to go here and here. All right. So now, let me see. Okay, so if I is 0 and j is 0, that's really only this case here. That's the top corner. So I need to calculate the normal using this vertex and this vertex, and it's really just the same. It's the normal of this face right here is the normal of that vertex. So yeah, so let me do this. Let me say vector 3, I'll call this v right. It is the vector to the right of position here. So this would actually be a pointer. So that's I and then j plus 1. All right, so that's this vertex. Now I need to get this one, which is the one below it. So I'll call that v low. And that's going to be I plus 1, but then nothing added to the j. So with that, now I need to get the cross product of this vector and that vector subtracted. Yeah, so this minus that and that minus that. So vector, actually I can just go ahead and set the normal, I believe. So the normal is the cross of, I think I want to go counterclockwise. Well, I'm going to try going counterclockwise. Let's see. So that minus that and that minus that. Okay, so I want to do v low, no, that point to whatever v low is pointing at. V low minus position, and then I want to do, wait, I think it's probably better if I do V right. So I'm going to do this way and then that way. Oops, that's minus position. Okay. It does compile. If I run it mostly dark, because really I'm only considering one corner in this case, and nothing looks lit up. Okay, that's probably... Oh yeah, and I also want to normalize this. You know what? No matter what, I'm going to normalize it. So let me just do this. Yeah, so after I calculate the normal, I'll just normalize the normal. Okay, so it's not showing anything, and I think that's fine. Okay, so that was this corner only, so now I need to do this corner, and that's more or less the same, but it will be V left here, so I'll do VLT, and that's going to be J minus 1. And so this case, I think I want to go, wait. Oh, this is different because there's actually two triangles that are affecting this, this point. So I want to get the normal of this face, the normal of this face, and then average them. So this face is, oh, so I actually need to get this vertex too. Yeah, let me see. So let me get another vector 3. I'll call this V low right. And so that's I plus 1 and then J minus 1. Okay, so I got these 4 points. So that's the position, that's VLR, that's VLT, that's VLO. And so I need to get the normal of this face, the normal of that face, average them to get the normal of that vertex. So this is going to be vector 3 F1 is equal to the normal of, actually I don't need to, I don't think I need to normalize it. I'll just normalize it at the end, right? Yeah. So if I want this. Yeah, okay, sorry, just trying to make sure I got this right. So this is the cross product of VLR minus VLT. And then also the position minus VLT. Why did I call this F1? Guess it doesn't really matter. Okay, so that's the normal of one face, and then this is the normal of the second face, which will be, I think, okay, so I want to treat this as the point. So this is going to be position minus LO. VLO, and then this is going to be Wait, position minus VLO, and then VLT minus VLO. VLO. Okay, I think that's right. And then I want to average these together. So I'll say norm. Wait, so then, yeah, this is not that. So norm equals N1 plus N2 times 0.5, which is dividing by 2. Okay, busted. 495. What's wrong? Left-hand type vector 3, there are no acceptable vectors. Oh, that's why. There we go. I have no idea if that's right. It actually does not look right at all. But it might. I don't know. I'm going to keep going and then just adjust it there. Because that's... I don't know. It seems kind of weird. Okay, but anyway, so if it's in the middle, I have to now consider the normal for this face, and that face. All right, so yeah. So here I have V left, V low, VLR, and then I just need V right. And that's J plus 1. So now I need to get the normal for this face, and this face, and average them all together. So that's going to be another normal here. 3 plus N3, and that's times 0.3333333. Repeating, of course. All right, so now I just need to fix all this. So the first face is VLT wait, hold on. That should be VLL actually for V low left. Yeah, okay. All right, yeah, so this first face is VLL. Okay, so VLL minus VLT, and then position minus VLT. Okay, so that's that one, and then so the next one should be this one. So, but now I'm getting confused. All right, whatever. So this should be VLT minus. Wait, but I'm trying to calculate this point here. Yeah, so that's position minus V low. Okay, never mind, that's right. And then VLT minus V low. Okay, yeah, so that's good actually. And then so now this one should be V low minus position, and then V right. minus position. All right. Okay, I got something here. I don't know if that's right, but it's really hard to tell when I'm just doing one edge of the texture. Could be right, could be wrong, I don't know. Okay, so let me now consider, since I got this edge here, I'm going to skip the middle area, which is all of this, and then just do the bottom edge. That's very similar to what I got here. All right, so but now if j is 0, so now I'm talking about this. Oh wait, hold on. That's not right. This should go here. All right, so now I'm talking about the bottom row. And so if j is 0, now I'm talking specifically about this one. And what happened to my face? I mean, not face, I had another line here. It should go here. There we go. Okay, anyway, so I'm talking about this one, so now I have to average these two faces here. So this face here, okay, so first of all, I need not V right, I need V, oh no, I do need V right, but instead of V low, I need V high, which is I minus 1. And then I need V HR. Which is I minus 1 and also J plus 1. So that's that point here. And so yeah, I need to get the normal of this face and the normal of this face here. So this one is going to be more like this. So this is position minus V high. And then this is VLR minus V high. No, VHR. Minus V high. Okay, so that's that normal, and now I need this normal, which is VHR minus VRT. And then this is going to be position minus VRT. All right, so that should be that. Yeah, oh, whoa, something broke. Let me go ahead and actually delete that and then copy this and paste it here and modify it because, all right, so this block here is for this, specifically that vertex, and now this is this vertex only. So this is just one face actually, so this is going to be more similar to that. But instead of V right, I need V left, and instead of V low, I need V high. So V left is J minus 1, V high is I minus 1. And so to calculate this normal, I need V high minus position, and then this is going to be V left minus position. Sure. Okay, the edges look a little bit better, but I don't know. Still can't tell if it's right. I'm just going to keep on trucking. All right, so now again, everything in between, which is 1, 2, 3 faces. So similar to what I got here. So I do need a V left, I need a V right, and I need a V high. And I need a VR, VHR. So that should be I minus 1, and then VHR, which is going to be I minus 1, and J plus 1. Okay, so for this one, I need V high, V high minus position. Not V pos. And then this is going to be V left minus position. And so this is going to be, wait, so that's that triangle there. So then this next one, I need position minus V high. And then I need VHR minus V high. So that's that triangle, and now I need this triangle, which is VHR minus VRT. And position minus VRT. And then average those all together. Whew, okay. So looking like it might be right, I don't know. The real test is this middle section here. This is where the bulk of the issues lie. All right, so now we are talking about the middle row, but if J is 0, we're talking specifically about this guy. And this is an average of 1, 2, 3 triangles. So it's going to be similar to this. So instead of V left, I do need a V right. So that's J plus 1. I don't need a V right, but I do need a V up. Or V high, which is right there. A V high right, which I got. And a V low. So this should probably be V low. Okay, so the first face is this one here. So I need position minus V high. And then I need a VHR minus V high. All right, so that's that one. And then so now this one, I need VHR minus V right. And then I need position minus V right. All right, and then now this one is V right minus position, V low minus position. Wait a minute, something's not right. I think I put too much stuff. Completely pasted that in the wrong area. Jeez, how embarrassing. Okay, geez. Okay, so that should actually go here. Ooh, I gotta do all that over again. Okay, let me double check this one. So this is here. No, yeah, here. confuse myself. So this is going to be V right, V low, V high, VHR. Yeah, so that should all be good. Let me just double check here. So yeah, okay, so that one's good. So now this one should be over on this other side here. So now that's going to be, so I need V left, correct. I need V, no, I don't need V right. I need V high, which I got. V left, VLL. So I need a VLL. That's I minus, no, plus 1, yeah, I plus 1 and then J minus 1. Okay, and then I need a V high, and then don't need a V high right, wait, but I do need, so I got V left, V low left, V high, and then V low. So that's just simply I plus 1 and J. All right. Whew. All right, so now the actual normals for the face are V high minus position, V left minus position. I got that, great. And then the next one is V, no. Yeah, so VLL minus VLT. So VLL minus VLT, and then position minus VLT. And then the last one is position minus V low, and then VLL minus V low. All right, then we average those together. Finally, I need to now calculate the normal for the middle ones, which is 1, 2, 3, 4, 5, 6 triangles I need to average together. So I need everything. I need V left, V low low, right? Yeah, so I need V left, V low low, V high, V low. I don't need VLT, but I do need VHR. And V right. And I don't need VLR. Okay, so I need 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it looks like I got them all. So I need, just to double check, I need VLL. Got it. And that's I plus 1, J minus 1. V left, J minus 1. Good. V high, which is I minus 1. V HR, which is I minus 1, J plus 1. Good. V right, J plus 1. Yes, I don't need that one, but I do need V low, which is I plus 1. Okay, that's all of them. So now I need to calculate all of the normals, average them all together. So 1, 2, 3, 4, 5, 6. Oops. Okay, so 4, 5, 6. Norm is going to be kind of something like this. Plus and 4, plus and 5, plus and 6, and then divided by, I don't know, 1.0 divided by 6.0. So that is how you average them. Okay, so now I need to calculate all of these. So N1, okay, so we're starting here. We're going to start in the lower left corner. So we're going to do this one, this triangle here. So that's LL minus LT. All right, and then we need position minus VLT. That's that face. All right, so the next face is this one. So we need V high minus position, V left minus position. Minus position, done. So that's that face. Now we need this one, so that's position minus V high, VHR minus V high, V high, VHR, oops, not CHR, VHR, minus V high. 3 out of 6 done. So now we need this one, which is VHR minus VRT, and then we need position minus VRT. There, and then that was that one. So now we need VRT minus position, VA low minus position. All right, last and not least, that was that one. So now we need this one. So we need position minus V low, VLL minus V low. Position minus V low, VLL. Oh, got it, great. Whew, all right, does that work? Probably not. Oh, maybe it does. It's actually kind of hard to tell, but it certainly looks a lot more dynamic than it did. I think it looks okay. I mean, it's hard to say because you want the faces facing away from the light to be in shadow, and I think that's what I got. Oh, you know what I need to do? I need to turn on the back face culling. Hey, Meatball's back. Sorry, I had my paint thing covering the chat, so I didn't see. Anyway, let me check out your sphere mesh. Oh, it's just the code. Right on. Yeah, it's pretty straightforward. Cool. Yeah, I've been trying to improve the normals from my terrain. I don't know, it's kind of hard to tell if it's working, but it definitely looks a lot better than it did. So when I look at it from straight up, yeah, I think it's working because all the faces that are facing away from the light are dark. But let me try to improve the resolution of it, and then maybe it'll look better. Wow, that is some ugly code. Yeah, so if I were to crank this up, let's say, what if I made it by 256 by 256? Should just be a lot larger. Yeah. I'm gonna say that's good for now. Yeah, so I obviously need to improve the layout of it, like make it less rugged, but I don't know, that was a lot of work. I'm gonna consider that a success. But what I would like to do is actually change the texture of my terrain and make it kind of look a little bit better. So what am I gonna do for that? I'm gonna just use Blender and just whip up a really quick ugly texture. Let me see, UV texture paint, here we go. Hold on. There we go. Okay, so all I'm going to do is change the color. Make like some kind of green, some kind of dark green. There we go. Where's this? There we go. So I'm just going to kind of just patch in some green here. And then change the color to be a brown. Throw in some dirt. Maybe a dark brown kind of thing. Maybe lower the strength. All right, sure, why not? Let's call that good. And then, so I want to save this. How do I, yeah, here we go, image, save as. Desktop terrain.png, perfect. All right, so then I can export that. And texture exporter, image to export. Let me actually look up what image it is. Just terrain. Terrain, I will put it on the desktop. And I'll call it terrain. There it is. All right, and then so now I should be able to say that the terrains.mesh.texture is equal to the states OS functions dot create texture 2D from file terrain dot textpix, and it is 4 bytes per pixel. Ooh, there we go. Okay, it's starting to really look like some terrain now. I'm going to raise the light up a lot higher though, so it looks like more of a sun. Let's put it at, what about 100? Is that too high? Oh. Okay, still just vibing there. All right, this terrain is coming along. Let me do something else just real quick. Let me multiply this by something. So it's just a little bit more bumpy. Yeah, that looks really ugly. I get some flickering in the background too. That's not looking good. Whatever. Okay, yeah, so let me see. How long have I been going for? It's been about an hour. I'm gonna go ahead and call it a day. Yeah, I think that's good. I think I got the normals working. I still can't tell. But what I'm gonna do next time is try to smooth out the terrain using my Perlin noise function on that maybe, and then I don't know. Let me see what's on my to-do list here. Terrain generation. I'm not going to call that done yet. You haven't had your coffee yet? I know we're different parts of the world, so your coffee time is my bedtime. or beer time, depending on what day it is. Yeah, probably 1 or 2 more days of terrain, and then I'll call that good for now. And then I don't know. I'm still trying to figure out what game I'm gonna make with all this technology. It's Monday. It's Monday, and I hate it. Yeah, the trick to loving Mondays is to get a job that you don't hate. I realized, or just no job at all. Yeah, I think I am gonna go to bed. Not right now, but pretty soon. It's almost 9 o'clock on my time, p.m. on a Sunday evening. And speaking of Mondays, I have one tomorrow coming up. So yeah. So sorry, Meatball, but yeah, I'm gonna wrap it up here. Let me go ahead and add everything. Commit, improve. How do I spell improve? There we go. Terrain. Thank you, Meatball. I will rest well. Hope you enjoy your Monday for whatever it's worth. And thank you for joining me, and I hope to see you next time. Good luck. Have a good one.